This conference will now be recorded.
Hello, everyone. I'm Maurice McHugh, the Deputy Lead and Future Capabilities Manager for the GOES-R Product Readiness and Operations team. And welcome to the Satellite Book Club Seminar Series session number 145. The talk we will have today is an introduction to NOAA's Near Earth Orbit Network, NEON. Our presenter is Tim Walsh, JPSS Program and NEON Program Director. Our facilitator today will be Chris White, Applications Integration Meteorologist from NWS Huntsville, Alabama. Before we get going, please be reminded that this session is being recorded. There will be questions and answers after the session, and I would really like to encourage attendees to post their questions in the chat room, and we will field them through there. Also, please sign in with your full names or specify your full name when asking a question in the chat so we can respond to you directly. Please also remember to check your spam folders on a regular basis on your email system, as they may occasionally reroute TowerS communications there. We're also looking for future presenters. Feel free to contact the TowerS team of Kashad Bowman and Emily Maddox, and also the training team can help create training materials that may otherwise be unavailable. Contact Brian Mata for information or questions with respect to that. Before we get going, I'd like to thank the TowerS team, our producer here, Kashad Bowman. I'd also like to thank the Office of the Chief Learning Officer, the GOES-R program, the JPSS program, and our facilitator, Chris White. Timothy Walsh is the director of NOAA's Joint Polar Satellites program, Joint Polar Satellite System program, and the new Near Earth Orbit Network NEON program. Tim has more than 26 years of experience supporting NOAA satellite programs. He joined the Senior Executive Service as Deputy Director of NOAA's Office of Satellite and Product Operations, OSPO, in January of 2021. Prior to this, he was the JPSS NOAA Deputy Program Director from 2018 to 2021, where he supported preparations for the JPSS-2 launch. Tim also served in a number of roles in the Geostationary Operational Environmental Satellite R-Series program, otherwise known as GOES-R, including acting program director for the GOES-17 launch campaign in March of 2018, as well as the deputy program manager for the GOES-R flight project, where he supported the development, integration, testing, launch, and checkout of the GOES-R instrument, payload, and spacecraft. Tim, welcome to the Satellite Book Club, and please begin when you're ready.
Great, thank you so much, Morris, and welcome to everybody who's joining us today and who's here today with us. Why don't we, well, first let me start out, actually this first page is kind of very illustrative of our mission. We don't have a NEON logo yet, but the Earth that you see in front of you actually has 3 different orbits displayed. If you look at, imagine that you're the sun and you're over Texas at this point, and the orbit to your right, or that light blue orbit, the kind of middle blue orbit, is the one that we supply for JPSS. It's otherwise known as the early afternoon orbit. That orbit stays stationary relative to the sun all the time. So it gives the meteorologist a unique perspective of the Earth at that time. The Europeans have another orbit, the lightest blue orbit, and then there's an orbit that you might imagine at the Terminator, which is that darkest blue orbit. We'll talk a little bit about that later today. I will say, as Morris introduced me, that I'm a spacecraft person. I worked on the geo side. I am most notably not a meteorologist, but I love to talk about the science. I love to talk about the meteorological mission and other missions that we have. So I'd be happy to take the questions, but definitely I'm not a meteorologist. So let's go to the next page. We'll talk a little bit, we'll jump right in. So the purpose of today's briefing is really twofold. We really want to tell you a little bit about NEON, the Near Earth Orbit Network, a name that is bound to have a lot of really good launchware, you know, where we're certain. We'll have, it is really all about data continuity for the science community that we support today, the operational, meteorological, and other communities. We do want to continue that microwave and infrared sounding mission. The VIIRS is near IR and visible wavelength imager, and then we have an ozone mapping and profiling suite. These are 4 really bedrock instruments that we supply in JPSS, and we want to propagate those measurements into the 2050s. Our near-term focus will be on those highest priority global observations, and I do want to stress that we are in fact global. just to poke a little fun at my geo friends. We do, unlike GEO that has the opportunity to hover over essentially one part of the Earth at all times, we do orbit the Earth 14 times a day, and in that that's unique sun-synchronous orbit, that gives us the opportunity to see the whole Earth twice a day, and particularly the poles. We do have on the LEO side, or what I'll refer to LEO a lot, low Earth orbiting. My new office name will be Low Earth Orbit Observations. At Goddard, we're known as the LEO Programs Division. At NOAA, we have a second name, the Office of LEO Observations. So sometimes when you hear me say the word LEO, it's just related to that mission area. NEON you could think of as a partner. It is going to take over the mission of JPSS, much like POSE was the precursor to JPSS. JPSS is the precursor to NEON. We're going to focus on, with NEON, we did something a couple of years ago called the NOAA Observing Systems Architecture Study, or NSOSA, a NOAA Satellite Observing Systems Architecture Study, NSOSA, and one of the activities or conclusions that came out of that was to reinvestigate or look at mature LEO systems as perhaps some platforms for our new sensors. And then finally, we're really focused on reaching out to the user community, everything from our bedrock customers like the National Weather Service to our partners at NASA and others, all the way down to the firefighting community and farmers and others. And then finally, I'm going to talk a little bit about what the NEON program is today. Let's go to the next, please. So we are, some of this is boilerplate, so I'll go quickly. We are all about weather forecasting. Really, the 3 to 7 day forecasts are what we're all about. I described our mission to the Deputy Secretary for Department of Commerce as like, we're the engine room. We supply a lot of that fundamental basic data that the American Weather Prediction really requires. We also look at disaster management. We support disaster management in terms of working together with GEO, looking at fires, whether it's fire, observations or smoke modeling and atmospheric composition impacts that could result from fires. And then floods with precipitation evaluation, and then the observation of actually where the flooding is happening. And then we look, of course, we have really stable sensors. So we're looking at global climate change with highly calibrated instruments that we have on orbit. Emphasize again that we're truly global, and we have a lot of significant products that we'll just touch upon a couple of them today. Let's go to the next. I do want to say one thing before we leave. Sorry, is that the first weather satellite ever launched was on April 1st, 1960 by NASA, called TIROS-1. We're really an extension of that mission. So NOAA came around in 1970. And we kind of absorbed that TIROS mission. Those POSE satellites became real bedrocks for the NOAA and larger meteorological community, followed by JPSS, now of course by NEON. So we have a tremendous legacy that we're trying to keep continuous. Next, thanks. This is one of my favorites. This is I refer to this as my DC to light electromagnetic spectrum, but it is truly not DC. You can see radio occultation starts around 1 gigahertz or so. And you can see as you march from left to right, a lot of the different observations that we make in the low Earth orbiting realm. And some of these are ones that we partner with today, whether it's radio occultation, including commercial data products that we purchase at NOAA, to some others that we are working with other entities like EUMETSAT, JAXA, NASA, of course, and others. If you start in the middle where you see microwave sounders all the way to the right, those are the bedrock instruments and observations that the JPSS program provides. But I do like this chart because it really shows the breadth of what we provide to the user community by either partnering or building. Next page. So we found that, you know, if you think about it, the JPSS instruments were created or defined requirements-wise over 20 years ago. They're even older than GOES-R. And so I love, you know, like we're building J3 now, JPSS 3 right now, and those instruments are phenomenal. They're rock solid. They went through, for those that know what a PSR, pre-ship review is, we went through without any request for actions for any of the 4 instruments. That is rare, and it just shows how stable and wonderful those instruments are. But they're 20-year-old instruments, and we can't necessarily fly them for another 20 years beyond. It's probably not sustainable, and we want to address what the scientific community wants as a higher form of iteration than every 20 years. So we are looking at improved microwave and infrared soundings, if you look to the left. We are also looking at other things, and what we're doing today in NEON is defining those high priority microwave and infrared soundings first, but then also looking at prioritizing instrument observations and that either we would have to build or otherwise partner with. But you can see atmospheric chemistry, ocean color, and other things. In fact, right after this talk, I'm getting to go see the PACE spacecraft, which is a wonderful LEO spacecraft that NASA is building for ocean color. So, and I do want to emphasize too that we're branching off from our what I would say our bedrock customer, the National Weather Service, and looking at National Marine Fisheries and National Ocean Service. The administrator of NOAA is an oceanographer. We definitely are expanding our perspective, so to speak, to other products as well. Next page. I'm going to spend just a couple of seconds on this one. I do love this chart. It's fairly new, but kind of describes the breadth of both the lifetimes and the partners for our various observational platforms. You can see some of my favorite old spacecraft all the way to the left, the POSE spacecraft, 15, 18, and 19, built and here, not built here at Goddard, but managed here at Goddard many years ago. Some of them are over 20 years old now, but still providing good data in a different observational location, orbit-wise, than the JPSS program. So actually, I'll show you some information in a bit that shows how important they still remain today. You can see all the various partners that we have there, but ranging up the top, you can see the missions that are so-called operational. The ones on the left are extended life, operational. And then you go to the ones that are in development, or what we call implementation, including the last two JPSS satellites. And then the ones in kind of the yellowish color are the ones that we're currently going to talk about today. They're the ones that are in conceptually being formulated. So they're coming together now. Next page. Here's a little bit of a flyout of our current constellation. I saw one of these from 1960, which is pretty illustrative of what the POSE constellation provided too. But you see the three remaining POSE that are quite old. And then the JPSS satellites that have been launching and operating quite well. SNPP was a Goddard managed project that's still flying today and providing great data. So we have 3 satellites currently in the 1330, or when I say 1330, that's that early afternoon sun synchronous orbit. And then we're going to launch J4 and then J3. Don't be deceived by the switch and tail numbers, but we are actually in the process of building J3. We'll put that into storage. Then we're going to build J4 and put a unique NASA instrument on there too. So that's why we're going to launch that one first. In concert, I will talk about the pinkish magenta ones up above in a little bit. Let's go to the next. So why do we do this? We do this because if we're in the process of doing economic benefit analyses for all of our instruments, much like GeoXO did on the Geo side. We really look at all the value. You can clearly justify what we're asking for in our congressional requests. It more than pays for itself. The return on investment is tremendous. I won't show those numbers here, but you can imagine it's quite a bit more. It's a function of GDP. The lowest numbers I had seen were on the order of $18 billion annually. Next page. I know this group I know this extended community knows the NASA NOAA community well. There's plenty of other users of our data. I recently saw a vegetation index picture that USDA was using to look at crop yields and other things from the VIIRS instrument. So a lot of very cool stuff. We're also working with DoD as well. Some may remember that our predecessor program, the NPOSE program, was with DoD, and we still remain partners with them today. And then internationally, we are truly global. So we are sharing data very equitably with our European and other partners. Next page. I'm not going to go into great detail on this one. I just wanted to give you a sense. This is a former, it's actually the strategic plan for NOAA has been updated, but these are the main emphases for the NOAA strategic plan from a couple of years ago. And it really does show that the National Weather Service was really focused on what they needed. That's been our bedrock for many years, but then we're also branching out to look at oceans and fisheries, and also our research community, which is focused primarily on climate at this time from our instruments. Next page. So I'm gonna have to put my glasses on for this one, but I do want to show this graphic does a great job showing the upper left or the middle left it shows the microwave and infrared microwave sounders and microwave imagers, which we partner with, shows their contribution as a function of numerical weather prediction. This particular data is from ECMWF. And on the right, you see some information right from here at Goddard, the GMAO group that shows contributions from various instruments. And I know that there's some, you could do a lot of analysis that could possibly show, I've heard really good and very smart people argue about some of this data, but I do think it shows that the importance of microwave soundings. Specifically, you can see ATMS, you can even see the AMSUs from the MEDOP and NOAA spacecraft that are really the actual POSE platforms. Next page. Here's an example of that many have seen, and I have in-laws that live on the Jersey Shore, and so they were impacted quite significantly by Hurricane Sandy a couple of years ago, and now over 10 years ago. And you can see the black dots are basically the actual truth, and the red dots were if you did a data denial. There was a data denial experiment performed again at ECMWF, and it showed what the data would have looked like without the LEO forecasting contribution. Next page. A little bit more National Weather Service applications, and again, for those true meteorologists out in the field, I probably cannot do this at the service that you can, but NewCaps is an example of some of the sounding products that the National Weather Service uses today. I know that there's some National Weather Service people online. Recently had an opportunity to go to the Sterling Regional Field Office where I saw some of this data in action with, of course, a lot of the geodata that was being overlaid. It was very helpful, but also ocean winds and atmospheric motion vectors or 3D winds, low light imagery for meteorology. In fact, I don't think of the day-night band as something that you'd use for meteorology, but in the lower right-hand corner, you can see that at night you could actually look at low stratus and fog. And I wasn't exactly sure how that would be utilized, but I was told to emphasize that, because actually I will say the daylight band or low light imagery that we do from the viewers is used a lot for post disaster recovery and some other things with our DoD customers, but I increasingly saw that it's being utilized for the meteorological side as well. Next page. I love this one because I'm going to go look at the PACE spacecraft next, but in the middle there you see the ocean color product as a function of a number of days or weeks. You can see the seasonal movement based on where the sun is and where the satellite can get the data, because it requires a unique sun angle. And so that's the PACE satellite will take this to the next level from a global perspective. And then interestingly, at night, you can use the viewers data also. Other elements, law enforcement and otherwise, have used it to identify where illegal fishing is occurring. This particular picture is in the Southeast Asia, but we've talked recently to some friends, some colleagues in Norway, and they also utilize our data as well. Next page. National Ocean Service, whether it's sea surface temperature or laser altimetry, this particular data, I believe, is from the JASON program. Also very closely coordinated with the NASA side, looking at sea level rise and other climate-based climate factors as well. Next page. Again, here's a better picture of sea surface temperature that was from the Coral Reef Watch daily page. Next page. And then finally, not finally, but probably our next biggest focus area is the area of climate. We have a number of our teammates actually in Oslo today at a World Climate Data Conference. And whether it's methane in the upper right-hand corner or the ozone hole in the lower right, there's a lot of areas that are looked at. And again, I mentioned that these instruments that we're providing really are highly calibrated and very stable. And over the period of years, that's so critical to this particular data record or series of data records. Next page. And here, I think, if you would mind, Shad, hovering, there we go. So here's a little bit of the ozone hole monitoring. We do have two types of instruments that are used in our ozone and mapping profiling suite. There's a nadir pointer and a limb imager that's also provided by NASA. So this is one area that we're closely looking at as well for our mission. Next page. Finally, here's some mean temperature anomalies over the poles. This particular is of course, over the South Pole. You can see the data anomaly can be quite severe and is sometimes a precursor to what we can see worldwide. Some may have heard that there's quite a few impacts on the extreme latitudes that are somewhat alarming in the climate community. Next page. And again, here's sea ice age derived from polar satellite measurements. I also will point out on the right-hand side, that's an example of something called that high-resolution rapid refresh smoke model, where we're taking observations, in this case, from the West Coast and some fires in Florida, and propagating using numerical weather prediction, how that smoke is traveling across the country. It can be used for air quality forecasts and other things. Next page. We travel over the poles. Again, it's 14 orbits a day, so every 90 to 100 minutes or so. And so a lot of our users are real-time users, whether it's in Alaska or in the various northern latitudes. And also, we actually take a lot of our supports at McMurdo Station, Antarctica, and there's a lot of users in the southern hemisphere that utilize our data on a real-time basis as well. Just like GOES, we provide the data both, we provide it in a stored fashion, but we also provide it in real time for those users that can catch the data. Next page. And this is another thing that's being looked at from a climate data record perspective. But here's Arctic sea ice. The yearly minimum you can see has been reducing over the years, and this particular record is from 1984 on. Next page. And a little bit more. Let's go one more because I do want to get to the program stuff. So okay, so now we get to NEON, we're looking. I'm going to try not to get into requirement space too much with this crowd because it could get boring quickly. But I do want to let you know that we get a lot of our data, our NESDIS level requirements from our parent organization. And we look at what we can provide from the LEO perspective. In this case, we're separated into certain areas for geophysical products, atmospheric, cryo, land and surface hydro products, and then water and coast. We do not look at space environment. We have another organization within NESDIS that does that. And you can see that the only Earth-pointed information that we do not detect is lightning. Next page. So what we do, and whether it's space weather, whether it's LEO, GEO, or space weather, we're all reaching out to the users to get information to inform our next generation systems. And we've had a number of items here as we prepare for formulation for NEON and prioritize that information or those observations. Whether it's working, we've had workshops in a number of major areas, whether it's microwave soundings, IR soundings, vis-IR imaging, or UV vis near IR atmospheric composition. And then we have a number of annual events as well. But these are going to be ramping up as we go into the next two or 3 years. Next page. So I will not go into great detail here, except to say that we've had, for each one of those user engagement workshops, we went into great detail into a lot of the users provided papers where they displayed the utility of the data, showed what the data is doing today, and what they anticipate needing in the future. And if you go to the next page, I think each one of the workshops provided a publicly facing report that can be retrieved from various elements, whether it's BAMs or otherwise. Next page. So I'm going to talk a little bit about, what's the next step? How are we going to do this follow on to JPSS? One more. So we are focused on, there's something in the NESDIS strategic plan that talked about evolving our LEO architecture to an enterprise system of systems. That sounds like a lot, and it is, but it's really to mature what we do today in terms of, as we were looking at those various orbits, we share the data we have with our European and other partners, and we get data from them. And we also now are increasingly getting data from the commercial sector. So we're looking at that, and we're also looking at trying to exploit some of what we've all seen with the so-called new space. And new space, some people may have heard of, well, I know everyone has heard of SpaceX Starlink and other things, but what we're seeing objectively is a lot of satellites in orbit. It's a different way to look at satellite production. Today, we analyze and test everything to the nth degree. We may decide that if you could show empirical data on orbit that shows the satellite performance, that it could be so-called commoditized. I'm not sure I'm there yet, but we're looking into what that means in terms of future spacecraft development. From a NOAA perspective, we're all about the science, we're all about the instruments. So we definitely want to get to a place where we can do most of our investment on the science, on the instruments. And so we're on the LEO side, you have more of an opportunity than you might have on the GEO side to look at smaller buses that are created at a high volume for the low Earth orbit environments. So that's what that means. Why don't we go to the next page? So we have a couple what I'll call program tenets. We were informed by the NOAA Satellite Observing System Architecture Study, or otherwise known as SOSA. It was publicized a number of times in a bunch of different forums, whether it was AMS or otherwise. But we are focused on that dependency on the various partners. A loosely coupled program. Now, a lot of people don't know what that means, but here at Goddard, we manage programs in a number of different ways. Single project programs are more of the bigger monolithic programs, like formerly GOES-R. I don't know exactly what GeoXO is. But loosely coupled programs are interesting to me because it allows us to focus on development in the near term and then maybe turn that crank in another 5 to 7 years to get the next highest priority observations going. So a loosely coupled program does not get kind of defined at one fell swoop. It basically, you could actually iterate a little bit more. And I think from the scientific and user community, it allows us to really address things that are becoming higher priority over time. Also, I talked about the exploitation of new space. And with that comes that last bullet, which is it's really hard for us to accept risk. For those people that have launched satellites in this environment, we test everything a lot. We only accept launch vehicles that have 99 point something % on orbit or to flight performance success. So there's a lot of things that if you can define a place where you can have instruments that are easier to replicate and put on smaller platforms and launch on a higher cadence, you can accept a little bit greater risk. And so to me, it's kind of exciting. It gives us an opportunity to try to do things a little bit differently, but more importantly, provide user data faster in different orbits, more than we could have done in the past. But more importantly, in that bang box in the bottom is that we are really trying to focus on first looking at what we can buy and partner with other elements, other users, and then we'll build what we must. But it may look like something like JPSS. It may look like something that has a number of different observations that currently are not on our platform. Next page. So we have two things that I want to talk about today, and how are we doing on time? Okay. So we definitely want to talk about two different projects that we're starting up here at Goddard. And when I say here at Goddard, the JPSS and NEON programs are physically located at Goddard, and we use a lot of Goddard facilities. The QuickSounder project is our first project. From my experience at NOAA, it's a first opportunity to do something on a Pathfinder basis as far as a launch. But what we're doing is we're actually repurposing an engineering development unit for ATMS, or Advanced Technology Microwave Sounder. We're currently refurbing that instrument in Azusa, California, and we're going to launch that within 3 years. And so it's a huge challenge. I think I look at it as I like to be competitive, so I love the idea that somebody gave us this challenge. And so we're currently in the evaluation stages. I won't talk to great detail about that because of that, but we are going to launch by the end of 25, early 26, and then we're going to use the information from that project to inform what we're calling Series 1. Now, it will have a better name over time, but Series 1 project is going to be a small one instrument per satellite constellation that will have two different types of two different types of instruments at present, which is microwave and infrared sounders. Essentially, you can think of it as the next generation ATMS or microwave sounder, or next generation CRIS, which is our infrared sounder. And we are hopefully planning to be able to be launch ready in the 2030 timeframe. We want to have enough overlap with our current constellation so that we can do that cross calibration between platforms over time. And then finally, we're creating a new partnership project, which we have so many partnerships now that we're actually kind of consolidating them into one group. It's not as exciting because there's no hardware involved, but it is still critically important to know. Next page. So this is an example of some information that could provide, like we look at Quick Sounder and Series 1, you can see the foundational products from those elements. And then as you move over to the right, the geophysical observations or products that come from those observations. And then you can see some an example of what these are just examples. You can see they're just defined as mostly TBC. But collaborative missions are missions that we actually have a stake in with other elements. Then leveraged missions are, in this case, these are two DoD missions, are missions that we actually do trade data. In this case, with a electro-optical satellite called EWS and a microwave imager satellite called WSFM. Next page. So because we're in the middle of source evaluation here, I won't go into great detail here. This is mostly, everything here is publicly accessible. The ATMS EDU is an instrument that's 20 years old as a design, but we're going to launch it and put it in the Terminator orbit, which is a underserved orbit from NOAA's perspective. And it's an 85 kilo instrument. It's actually quite well packaged and really a great instrument, but it will be put on a satellite that is as yet undefined. That's a quick sounder concept to the lower right. We don't know if it'll look like that, so we should know within a year. I should say we'll have the award within by fall. So next page. Then we start to think about, we use that information to look at the Series 1 project, which, as I mentioned, will have two different types of instruments. Those instruments will be able to be launched into either of two orbits, the 1330, which is our bedrock orbit for NOAA, and the 1730, which is that so-called Terminator orbit. And so I think we're in the process of going through all the right reviews with NOAA and our parent organization, Department of Commerce. And so more to come on that starting next year. But with that, we will also have a common bus that we're going to be creating to support either one of those instruments. And that's also hoped to start next year if we can all get the budget approved. Next page. We don't know yet what Series 2 is going to be. So that's the nice thing about the so-called loosely coupled program. You have we're planning to have those defined by 2027. Those next generation requirements. If you look at what JPSS is, it could likely include a VIIRS follow-on or an imager, and then an ops follow-on. But it may not. It may actually have a third instrument, or maybe two instruments that aren't exactly the same two that I just mentioned. So we're going to turn that crank through user engagement and other operational and user community reach outs. We'll get a better sense within the next year or two. Next page. So what is NEON going to do for NOAA? We are actually we are all about replacing JPSS, and more importantly, you look at that sub bullet. We're really focusing on making that timeline to get to orbit much smaller than it is today. I started working on GOES-R when it was in 2004, when we were just words on paper, and the instruments actually had started in 2001, and we launched in 2016. And whereas it's a wonderful satellite, we want to be able to cut down that cycle time by half. And so we're in the process of moving forward, and please stay tuned. And I hope there's some good questions, but I think it might be the last page. Yep, thank you. We're good for questions. Yeah.
Okay, so can you all hear me okay? I just want to do a quick mic check.
Sure can.
Okay. Okay, great. Okay, so well, this is Chris White again. I'm facilitating this SBC call, and I want to thank Tim again. It's a great pleasure to have you here as the director of the JPSS program and now the new NEON program as well. Let me just say a few things here. I would like to encourage attendees to stay on the discussion if you can. You have time to. Of course, we'd love to entertain any questions and have some Q&A. It looks like we got about 8 minutes or so to do that. And especially, from National Weather Service field offices or regional headquarters, and please specify your full names if you can when asking a question. Also, I do want to say that please join us actually next Thursday, June 1st, when Bruno Rodriguez, a meteorologist from the Denver Boulder National Weather Service office, will discuss a day in the life of an IMET. I personally think this will be pretty interesting. You want to talk about IDSS activities, listen to an IMET presentation, so that will be interesting. Also, if you have any comments or questions about the Satellite Book Club or need assistance with the configuration of satellite products, especially in your AWIP systems, the TowerS team is available to help, so please feel free to reach out to Kashad Bowman, as you see his email listed here, or Emily Maddox, and her email also listed here for any support. And also, I don't know if you know it, but you can find the TowerS in the NWS chat under TOWR-S. That's their chat room call sign. So. And also, I think Emily will post this here later, but following, please share any feedback you have on the session, and there will be a survey linked as well. So, all right, so getting back to things here, Tim, let's see if we have any questions from anyone right now. Looks like there's a few comments in here. We do have a question actually from Dan Lindsay. Nice presentation, Tim. What's the NASA instrument that will be added to J4?
Yep, and thank you, Dan, for that question. It is the Libra instrument. The Libra instrument is now you're gonna test my Greek mythology, but it's based on it's not an acronym. But the Libra instrument is going to be following the Ceres instruments, which were launched on the earlier JPSS spacecraft, SNPP and J1, and it's an Earth radiation budget instrument. And we're working with SMD at NASA headquarters to put it onto J4. And again, I mentioned briefly that it's launching on J4 because of where it is in the INT life cycle. And it just made sense to integrate it instead of taking J3 out of storage and integrating Libra on it. So we're very excited about that.
Okay, great. Thanks very much. And Dan, I'll let you chime in if you have any further questions. I'll move on actually to another one here that came in from Bill Schoberg. And Bill says, how's the LEO program leveraging lessons learned from the European next generation of LEO satellites?
Thanks, Bill, and great question. There's two ways to answer that are both very relevant. One of which is everyone knows the METOP, or many people know the METOP spacecraft. METOP B and C are still in flight, and they still fly some NASA-provided instruments, the AVHR, METOP, and AMSU instruments. Those are going to be, right now we're talking about extended life missions for them, including the support of the POSE spacecraft, but we're now currently supporting them at our McMurdo station support down in Antarctica. But as importantly, we're preparing for what will be the EUMETSAT version of JPSS. And I have to say, they've done an amazing job. They're having some delays because it's so ambitious, but there are two different types of satellites, EPS second generation A1 and B1. And between them, I think there's probably, I think, 8 total instruments, if not more than that, including some space weather type measurement devices or measurement sensors. But I do think that they're kind of out of phase with us, if you think of it, Bill. They're about where we launched, did most of our NRE for JPSS about 10 years ago, and built and launched the first JPSS. They're nicely about 10 years behind us, but they're about to launch an amazing new set of observations. And then we're both looking about what the next generation looks like, and they're talking about launching something called Sterna. Sterna is an Arctic tern. It's a bird, but it is going to have a microwave sounder that is, I won't say lesser than an ATMS, but it's going to have a smaller regime of sensed microwave frequencies. And it's going to complement both ATMS and the European version of the next generation sounder that they're about to launch. So I know that looking at some of the, I know you're a meteorologist, Bill, I'm not, but I do know that the more microwave observations you can get globally, it almost looked to me like there was a linear progression of forecasting performance. There was no asymptotic relationship that I could see based on the data I saw provided at the UMetSat conference I went to last fall. But it is something to think about. We're going to have these primary instruments in the ATMS and the European version of ATMS. And then we're going to be, between them, have these smaller, I should say, these complementary soundings provided as well. So I'm very much looking forward to that. So I think they've learned a lot from us as far as JPSS to their current version. And then we're going to go forward together and look and see what kind of complementary type of observations we can both provide. I will say that one common denominator for all that, Bill, is the use of McMurdo Station. McMurdo is kind of a unicorn of sorts for ground support because most everything else can be provided commercially as far as ground data receipt and routing. But the US government controls McMurdo Station, and there's no better station to be optimally positioned to get polar satellite downlinks on the South Pole. And so we are working with the Europeans to kind of integrate their missions into our systems down there, but there's soon to be so many of them, we're going to be running out of antennas, and we might have to look at alternative means of getting the data down, such as the phased array antennas or other things. Many more things we could discuss on that one, Bill.
All right, thanks a lot, Tim. I can say, speaking from a forecaster, you know, and you mentioned the NewCaps data set earlier. We have at least had in the hazardous weather test bed, the experiment that goes on, actually it's going on right now this week, data and NewCaps data from some of the European satellites. So in addition, that would provide late morning passes. And so that's been interesting too.
If you don't mind, I'd like to ask you a question about the hazardous weather test bed. Is that what's being held at Norman?
Yes, right. Yes.
Okay, because I remember going to that a number of years ago, and it was pretty tremendous work. So I'm looking forward to seeing the data from that you're talking about.
Yeah, right. Yeah, there's so they've used data from MEDOP instruments in the past. I don't think it's going on this year. Right now they have an experimental NewCaps forecast product, but there's some discussion about the incorporation of MEDOP also. But anyway. I guess I'll get back to some questions here. I guess we're out of time. I know typically we're slated to end at I guess it's 12:45 Eastern time, but if people can hang on, perhaps we can go just a little bit longer. I got a message indicating that should be okay. I've got a few more questions here if y'all are open to that. The next one here is from Joe Fiore. He says, "A great talk, Tim. And are there any plans to have a scatterometer on a future NOAA polar orbiting satellite?"
It's a great question because I was talking about it with Satya Kalori, our program scientist, the other day. I believe on the MEDOP spacecraft is currently the ASCAT sensor that we get most of that data from. Those two satellites are aging, MEDOP's B and C. I know that the new satellites, I forget whether it's on A1 or B1, will have a scatterometer for the UMetSat early morning, I should say mid-morning orbits. My question to Satya and the user community is, that's where we anticipate getting that scatterometry data at present. Now, the MEDOP satellites, and when they, upon their demise, I don't know where else, what other orbital planes will be required to get that full data set that we require, that we have utilized so far. So that's an excellent question. Right now, we're anticipating getting that data from the Europeans, and I don't know how. Again, that's specific to that one orbit. But that's definitely in the hopper for what we called Series 2. As I mentioned, that's one of the nicer things about this capability is that if we do deem the scatterometers as being required, say above, we're of course always practically limited by budget, but we would. That's one way that I think the real user community interface through user engagement will come in. Thanks, Joe.
Okay, all right, thank you very much. We do actually have another follow-up question from Dan Lindsay, and then I may have one after that. Dan writes, is the ATMS that will fly on the Quick Sounder mission ready to go, or does it need some additional work?
It does need some additional work. It was an EDU, and so it has one or two parts that need to be replaced, but I do think that it's very close. It was opened up, we awarded back in December. It was opened up in the last couple months, and it's currently being analyzed. It's been utilized for tests, so there's a certain value, there's certain amount of characterization that's been going on throughout. But it's interesting, because this is a proof of concept, Dan, we are not requiring them to have, we're not showing them contractually to meet the performance requirements that we would on a JPSS spacecraft, but I believe that it's every anticipation that it will look like an ATMS on orbit, but more to come on that. But I am confident that the satellite, we really want to get the ATMS refurbishment completed so it's not on the critical path to this, what is now less than 36-month launch requirement coming up. So yeah, we hope to deliver that within the next year.
And just a quick question for me, it may be a little bit early regarding this, but as far as how its orbital configuration comparison to current NOAA 20 and 21, how will that fit in? Do y'all know this yet? So I know NOAA 21 lags about 50 minutes or so from NOAA 20 during its passes. So
yeah, actually, if you think about it, SNPP and J1, which is now NOAA 20, of course, are 180 degrees apart in the same orbit. Okay. We launched now NOAA 21 exactly between them. So they're all in the same 1330 orbit, separated by 90 degrees. At least the two primary satellites, primary and secondary satellites, are still SNPP and J1 or NOAA 20. And then hopefully by this summer, we're going to name NOAA 21 as prime or secondary. That's an OSPO call, the Office of Satellite and Data Processing. Product operations, I should say. And so when they make that call, we'll keep them in that orbit. Now, it's very important to know that ATMS will not, the Quick Sounder ATMS will not be in that orbit. It's going to go to the Terminator orbit. And so it's going to be very different. It'll be, if you look at what the POSE satellites are providing right now, is we don't control their orbit. So they're slowly drifting over the course of their lifetimes. They're giving us some level of orbital diversity that, very ironically, we never intended to provide when we launched them many years ago. But now it is actually coming in handy. When they do die, and I've been told that NOAA is going to pull the plug in about 3 years or so, but I hope we can keep them going for a little bit longer until we can get Quick Sounder up there, supplying that observation from a unique orbit.
yeah, okay, great. And this was slated again about 2 to 3 years or so?
What, Quick Sounder? Yeah.
Yes, yeah.
We have a requirement to be on orbit, our launch commitment, I should say, by March 1st, 2026.
Okay. And then I guess, we're okay. We'll just keep going here. We have, at least I see one more question in here from Mordecai Cohen, and he states, what aspects of next gen ground stations are incorporated into the NEON program?
Thank you, Mordecai. I really like that question because it really flows into what we're going to learn from Quick Sounder. We are not defining the ground system data receipt, data routing for Quick Sounder. We're saying we're using the Rapid Spacecraft Development Office here at NASA, and we're not buying a spacecraft. We're buying essentially a system. We're going to provide them a GeoFeed or government-provided instrument, and they're going to integrate it, launch it, and receive the data, route the data, do the initial level 1B data processing, and deliver the data to the user in the cloud. And again, this is non-operational, so we're trying some things that we normally would not do. Now, that's not necessarily the case for Series 1, so we don't know yet what that looks like, but we're trying to see what a commercial provider could provide. I mentioned that almost every solution I know that's ground related looks at McMurdo as part of the complement for ground systems, supplied, of course, complemented by a northern latitude equivalent. For us on JPSS, it's currently Svalbard Island, north of Norway. But you never know. In another 5-10 years, satellite-to-satellite crosslinks may be the way to go. I know Goddard is looking closely at things like that, and we'll be keeping our eye on that as well. So you could imagine that the data latency goes way down. And honestly, one of my biggest questions going forward would be, could our users in the National Weather Service use the data as quickly as we could provide it, right? So that it's a whole end-to-end system. So currently we provide the data basically on a half-orbit basis, or 45 minutes. And so in other words, that means that the data that hit the focal plane or whatever the sensor was is as old as 45 minutes, sometimes younger than that. But what we're looking at in the future is maybe milliseconds, could be minutes, could be 15 minutes if you look at a global ground-based system. So it's a great question, Mordecai. There's really no easy answer at this time, but there's a big trade space that includes all of those factors.
Yeah, it's great. Of course, speaking from the operational community, and this probably goes without saying, is that, generally the faster we can get the data, obviously, the better. And that, whatever sort of operational challenge is meant to be addressed by that data, latency and resolution of that data, it's kind of tied in with, well, what is the evolution of the characteristic or the feature we're watching? It needs to be sort of in line that it can address that sort of, evolution on the time scales of whatever phenomenon you're looking at. So, but 45 minutes, we're used to an hour and a half or so latency with NewCap's data. It's sufficient. It can work. And so,
No, that's encouraging to hear you say that.
Okay, yeah, well, thanks. And there is another interesting question here. This is the last one I see right now. This is from Jose Garcia Rivera. Any plans on considering a synthetic aperture radar or SAR instruments or SAR data? As with scatterometers, we are currently relying on international partners as data, from the Europeans. SAR has proven quite valuable for the NWS for wind detection over oceans, in addition to other applications. Mentions flood, ice, etc. There are actually some evolving applications of SAR and something called NSAR data, actually for post-storm analysis and wind damage events. But anything you want to add or that you can speak to about SAR data?
I would say that that's a great get off the stage question, because I'm going to volunteer Satya Kalori to come back and talk to this group at some future time. All kidding aside, that is, I've heard people ask about additional access to more SAR data, and that could be something that could be addressed via Series 2. Right now, as you can imagine, and was that Jose? Yeah, Jose. If we can rank it and prioritize it above something else that we currently, within the available resources, we would do it. Otherwise, we will do everything we can to find, if somebody else is sensing it, to find a way to partner with them. Like the Canadians and others that have brought down really good SAR data. But great question. I can't tell you I have the whole answer for that, though, but it is in the mix for future observations.
Okay, and I don't know if we really have time for any further questions right now. So yeah, I think there is one more question in there, but I think I'm going to have to pass it off back to Maurice. And so Maurice, I will hand it over to you.
Thanks very much, Chris. I'd like to thank Tim for a great presentation. I'd like to thank all the attendees and for the great exchange of questions and answers. And we hope to see you all back here next week, next Thursday, noon Eastern, for the next edition of the Satellite Book Club.